My name is Laycee Morgan, and this is my video clip 3. My word problem looks like this. Jenny has 2 pieces of string. One is 12 inches long. The other is 30 inches long. She wants to cut her string to make as many bracelets that are as long as possible. So her questions are, how long will each bracelet be? And how many bracelets can she make that are that length? So what do we need to find in order to solve these problems? That's right, the greatest common multiple. We're going to look at 3 different ways to solve greatest common multiple for this problem. First, we're going to use unit blocks. Each of these represents the bracelets that Jenny has. This one is 12 inches long, and this one is 30 inches long. And we're going to use these to figure out what numbers can be broken up evenly into 12 inches and 30 inches. Well, we already know that 1 can go evenly into 12 and to 30. So let's see if 12 can go evenly, or if 2 can go evenly into 12. Yep, it can. Let's try 30. We're going to see if 2 can be divided evenly in 30 inches with no remainder. Yep, it can. So, do we think that 2 is the greatest common multiple? Probably not. Let's keep trying. Next, we're going to break down 12 inches into 30 or 3-inch segments and to see if they come out evenly. Yep, there's no remainders. Let's see if we can do the same thing with the 30-inch segments. We're breaking them down into 3-inch parts to see if there's going to be any remainders. That way we know if 3 can go into 30 evenly. Yep, it can. 3 can go into both 12 and 30 evenly. But I wonder if that's the greatest common multiple. Let's keep trying. Next, we're going to break down into 4-inch segments. Well, 4 can go into 12 evenly. Let's see if 4 can go into 30 evenly. Uh-oh. Nope. 4 can't go into 30 evenly because there's 2 left over. So 4 isn't a greatest common multiple here. So let's try 5. Nope, 5's not going to work because 5 doesn't go into 12 evenly. Let's try 6. Yep, 6 is going to work. 6 can go into 12 evenly 2 times. Let's see if 6 is going to go evenly into 30. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 can go into 30 evenly also. And since 12 can't be broken down any further, we know that 6 must be the greatest common multiple. So, going back to our questions, how long will each bracelet be? Well, we know that each bracelet will be 6 inches long. How many bracelets can she make that are that length? Let's look. 1, 2, 3, 4, 5, 6, 7. Jenny can make 7 bracelets that are 6 inches long. Now we're going to take a look at how to solve greatest common multiple 2 different ways. The next way we're going to look at it is using a timeline. We start with 12 over here, or 1 over here, and 12 here. And we know that 2 can go into 12 6 times. And 3 goes into 12 4 times. but 5 doesn't go into 12 at all. So the pairs look like this. Let's do the same thing with 30. Start with 1, end with 30. 2's pair is 15 because 2 goes into 30 15 times. 3 goes into 30 10 times. 4 does not go into 30. 5 goes into 30 6 times. So the pairs look like this. And we can tell by looking at our number lines that 6 is the greatest common multiple between these two numbers. The last way we're going to try is by breaking down each number. Like this, using a tree diagram. So 12 can be broken down into 2 and 6. 30 can be broken down into 5 and 6. We can see that 6 is the greatest common multiple here. Let's look at it one more way. This time we're going to break 30 down a little bit differently. Well, 2 and 6 makes 12. And if we break it down like this, 2 and 15 makes 12, we can break 15 down into 3 and 5. And we can break 6 down into 2 and 3. But if we look here, we don't see that 6 is the greatest common multiple. But if we look at each of the primes that make up the numbers, we can see that 2 times 2 times 3 equals 12. And 30 equals 2 times 3 times 5. And if we look at these equations, we can see that 2 times 3 is in both of them. And 2 times 3 equals 6. And those are 3 different ways that you can find the greatest common multiple.